Hello, so in this video we will be talking about a proof which says that there are infinite number of prime numbers. So let's start with what prime numbers are. So prime numbers are those integers which are only divisible by 1 and themselves. So by divisible, what I mean is that that number divides that prime number. So for example, if I say 8 is divisible by 2. So it means that if I divide 8 by 2, the remainder is 0. In mathematical terms, what I write is 2 divides 8. Okay. Okay, so now what we are going to do is we are going to show that there are infinite number of prime numbers. So the proof is by contradiction. So recall that a proof by contradiction starts with assuming something and ends up with stating something which is universally true and making it false. Okay, so now what we are going to do is we are going to start by saying that there are finite number of primes. So we will say there are only n primes. Okay, and let's write them in order. So prime 1, prime 2, prime 3 and up to prime, this is my nth prime. Now let me define q, which is equal to 1 plus the product of all of them up to p of n. Now the question is whether any of these p1, p2, pn, any of these pj, for example, where j belongs to 1 to n, so does any pj exist such that pj divide q? So what do you think? Now note that if pj divides q, then it means that, so if pj divides q, then pj should divide q minus the product y. Okay, let's see an example. Let's say that 2 divide 16 and 2 divide 12. Then 2 would divide the difference as well. Okay, now since if pj divides q, then pj, and already pj will divide the product because pj is one of those from this product. So if pj divides q, obviously pj divides this product, this one, then pj should divide the difference of them. But what is the difference of them? Now what is q? So pj divides q is what? 1 plus the product. And then I copy this again. So this product will cancel out with this product. So then we will be left with pj divides 1, which is a contradiction, which cannot be true. So can't be true. Why? Because 1 is the smallest positive integer we have. So any integer, if at all, should divide a number which is greater than that. So pj cannot be less than 1 if it is a positive number. Okay, so then this means, so we conclude that pj does not divide q. So this is a sign for does not divide here. Okay, if pj does not divide q, what does it mean? This means two things, one of two things. This means that either q is prime, okay, or that there q is not prime but there is another prime not in the list, that divides Q. Okay. So once we say that Pj does not divide Q, it can mean one of those two things. One is that Q is prime itself, or Q is not prime, but there is another prime which is not in the list of P1, P2 up to Pn, and it divides Q. Both of them, both of the cases mean that the assumption of n primes is false. So this means our assumption that there are only finite number of prime numbers is false, which means that there are infinite number of primes. So this is the formal proof of the theorem or the statement that there are an infinite number of primes. So hope it is informative and understandable to you, and hope you enjoy the video. Thanks for watching.